This video was brought to you by the ILC. Hi there, welcome to episode 9, Using Functional Notation. In this episode, we'll briefly go over what functional notation is and how to use it to evaluate a function. Let's have a look. The problem I have given you this time says if f parentheses x equals 2x squared minus 9, evaluate f parentheses 2. Now, if you're not sure what any of this means, this f parentheses x is not meant to be a multiplication sign. You are not meant to multiply it by anything. Instead, it is usually read as f of x. What this means is that this part of the equation to the right side of the equal sign has a name, and that name is f. This entire piece is referred to as f. Now, the part that's in parentheses tells you what f depends on. Since x is in parentheses, that tells you that this expression f depends on what x is. You can also say that f is a function of x. Now, if I tell you to evaluate f parentheses 2, again, that doesn't mean you're meant to multiply anything. This is usually read as f of 2 or sometimes f at 2. What I'm really asking you to do when I say to evaluate f parentheses 2 is find what f is if x is 2. You might notice that the x that's in parentheses here now says 2. So that's meant to direct you to replace this x with 2 and any other x that you see in this equation with 2. So let's give that a try. So most of the equation here is going to stay the same. We're going to have 2 times x squared minus 9, except for it's not going to be x anymore. It's going to be 2. And now we simply evaluate this expression by following the order of operations that we learned in episode 1. Remember PEMDAS? Here it is again. Well, there's no operations in parentheses. We can check that off. We do have an exponent. 2 squared is just 4. So now our expression reads 2 times 4 minus 9. That takes care of the exponents. We now have multiplication and division. Our multiplication is 2 times 4. That's 8. Still minus 9. Then we do additions or subtractions. All we have left is 8 minus 9, and that's equal to negative 1. So what we can say is f at 2 equals negative 1. So it's not too bad once you know what it all means. But now we'll give you a slightly more unconventional example. This time, rather than asking you to find f at a number, I'm asking you to find f at a binomial expression. This is going to start the same way as the previous problem. Most of the expression is going to stay the same. We're going to exchange all of our x's for a plus 2. So we'll have 2 times x squared minus 9, but we don't write x, we write a plus 2. Now, if you've watched my previous episode, you know that if you have a binomial with a square above it, you can't just square both terms. You have to do the FOIL method to get 4 terms. So let's go ahead and expand this expression here for step 1. We'll have 2 times a plus 2 times a plus 2 minus 9. Now, let us FOIL these two parentheses here in step 2. Well, a times a is a squared. A times 2 is 2a. 2 times a is also 2a, and 2 times 2 is positive 4. Now we have to give that whole thing its own parentheses, because we still have that 2 outside, and it's going to be multiplied by everything in this parentheses. And then we have a minus 9 on the outside. Well, now that we've completed our FOILing, let's move to step 3 and just distribute whatever we can. We're going to have 2 times all 4 of the terms that are in this parentheses. So we'll have 2 times a squared is 2a squared. 2 times 2a is 4a. 2 times the other 2a is also 4a. And 2 times positive 4 gives us positive 8. And then the minus 9 is still on the end. For our final step, to complete this problem, let's combine any like terms that we see. Well, we have a squared here, but I don't see any other a squares in the rest of the expression. Well, we've got 4a here. I do see another a term there, but there aren't any others. So we're going to combine those two into one. I also see a couple of terms that don't have any variables, the positive 8 and the negative 9. We can combine those into the same term as well. So let's do our last bit of arithmetic. Our 2a can't be combined with anything, so it is still 2a squared plus 4a plus 4a gives us 8a. And then positive 8 minus 9 gives us minus 1. And this is our final answer. So you can see functional notation sometimes isn't so bad, but if I'm asking you to find f at a polynomial, sometimes it can get a little bit involved. The algebra is a little bit tougher. But with a little bit of practice, you should eventually get the hang of this. Thank you very much for watching. We'll see you again next episode.